All right, team, for day 26, I want you to go ahead and download the PDF for 11.4, and that's going to be the slope-intercept form. The first thing I want you to do is take a few minutes and just go through and work through this warm-up question about the median income for U.S. males. Go ahead and pause the video and answer the questions. All right, hopefully you had a chance to work through them. So here are my solutions for the first half of it. So what is the title? Well, it's median income for U.S. males. What does the x-axis represent? Well, it represents the years 2000 to 2012. If you notice, that's the span that's being graphed there. For C, what is the y-axis? It's representing the income in dollars. And then for D, what does the point 2,000, 28,300 mean within this context? So what I want you to be thinking about here is when you have this X value and this Y value, put it back into the context of the problem. So with X is 2,000, that means you're dealing with the year 2000. And if Y is 28,300, that means that's going to be the median income for U.S. males in the year 2000 would be 28,300. For part E, finding the slope of the line, you need two nice points on the graph. So if you go back and you look at your picture, the only y values that I know exactly are going to be the two that are given to me in the graph. I could kind of approximate it, and I could probably do an okay job of guesstimating what the slope would be, but if I know those exact values, I want to use them. So I'm just going to highlight those points there because the 2,000 corresponds to the x value and the 28,300 corresponds to the y value. Same thing with the 2008 and the 35,300. So when we go back and we find our slope, I'm going to take those 2 points. I have them labeled x1 and y1 and x2 and y2. And this one I chose to use my slope formula, although you are welcome to set this up and make a table of values and find your change in y and your change in x. So setting up the equation, I get this first part in blue here, and I just want you to kind of notice that when I look over here, let me change my color real quick. When I look over here, do you see how the y2 and the x2 are stacked on top of each other? And then the next pair, I have the y1 stacked on top of the x1. That always needs to be true. Sometimes people like to do the y1 first and the x1 first. That's totally fine as long as you can look at this vertically and see that those 2 points go together. You have that x and that y coordinate going together. All right, so doing some simplifying, we end up with 7,000 over 8, which would simplify to 875. So that's the slope of our line. So for part F, what does that mean? Well, for every year increase, the median income is increasing by $875. So notice I put it back into the context. I have units involved, like with my dollar sign right there. And because it's a positive slope, that's how I know it's increasing. I can also look at the picture and I can see that that slope is going up and to the right. So I also know that it's going to be increasing. And the last part for part G, there's a lot of strategies that you could take here. My answer is not the perfect answer, but your answer hopefully is going to be close to mine. So if I know the median income in 2012 is about 40,000, I did guess because I don't know the exact number there. I added $875 to figure out the median income for the year 2013 as well as the year 2014. So I got about 41,750. As long as you're close to that, that would be great. All right, so we're going to take a look at graphing two equations here. So round one, I want you to graph the equation for 3x minus 4y equals 0. Now this doesn't look very user-friendly. I do give you a table of values here, well, I guess a blank table, and we could go ahead and figure out, we're going to have x on the left-hand column, and I would really rather this equation look like y equals, because we found the last time that it was a lot easier to graph things that were in terms of y equals. So I'm going to rewrite my equation, and I'm going to do a little bit of algebra on this, and I'm going to get it so my x value is going to be on the other side, so that way I can isolate y and write it as a y equals line. So I'm going to start by subtracting 3x from both sides. That's going to leave me with a negative 4y equals a negative 3x. Don't forget about that negative with the y. And then I'm going to divide both sides by negative 4. This doesn't look super pretty, but that's okay. It's better than what it started with. So y is going to equal 3/4 x. And that's what I'm going to put on the right-hand side of the table. All right. If we notice that that denominator is 4, that means if I pick values that are multiples of 4, it's going to make it a lot easier for me to come up with some nicer values. So how about -4, 0, and +4? That should give me enough information to get my line graphed. So let's take 3/4 times -4. That'll give me my y value. So 3/4 times -4, well, -4 divided into 4 pieces would be -1, and we're going to multiply that by 3. So I'm going to get the point -4, -3. And let's put a big old dot right there. I love plugging in 0 because 3/4 times 0 will give me 0. So that means I've got the point 0, 0. And let's plug in 4. So 3/4 times a +4. Well, 4 divided by 4 is 1. 1 times 3 is 3. All of those points are falling on a nice pretty straight line. That means I feel really confident that I have the right values. And I'm going to go ahead and draw a very nice long straight line with arrows on the end. Do not give me any little short stubby graphs because you want to take up the space that you're given. Because again, you are representing the infinite number of solutions that make up this line 3x minus 4y equals 0. Cool, there's that one. Let's try another one. All right, oh, that's cool. This one's already in y equals form. So I'm just going to go ahead and plug this in on the right-hand side of my table. And when I'm thinking about what values to pick, if that one has a 5 in the denominator, if I pick multiples of 5, it's going to make things a lot easier to work with. So how about -5, 0, and 5? So let's start with -5. I'm going to take -2/5 times -5, and I'm going to add 1, and I'm going to see what I get. So -5 divided by 5 is -1. -1 times -2 is +2. And 2 plus 1 would give me 3. Let's plug in 0. Kind of separate that out. Love plugging in 0 because anything times 0 is 0, and 0 plus 1 is 1. And let's plug in +5. So -2/5 times +5 plus 1. Let's see what that's going to give us. That's going to give us -2 plus 1, which gives us a -1. All right, let's go ahead and plot these. I should have been plotting them as I go, but I didn't. So let's just kind of hope here that we're going to end up on with a straight line here. So there's that one, and then the 0.5, -1 would be down here. It looks like those 3 points are lining up very nicely, so I feel really good about my graph. So again, a nice long line with arrows on the end. Awesome. Okay, what I want you to do now is I want you to go back to these two problems, and I want you to identify what the slope is for each of them and what the y-intercept ended up being for each of them. And then I want you to see if you can find those values in the equation. So let's go back to the first one. I'm going to get a different color. And let's find the slope. So I'm going to pick 2 points that are on my graph here, and I'm just going to count. I'm going to go up 1, 2, 3. So my change in y is 3. And let's find my change in x. 1, 2, 3, 4. And that slope is positive. It's going up and to the right. So my slope is a positive 3/4. Cool. Where do you see 3/4 in the equation? I see 3/4 right here. It wasn't obvious up here in the original form, but once we got it in that y equals form, I could really easily identify the 3/4. All right, so now let's take a look and let's find the y-intercept. So I have 2 places I can look. I can look in my table. So what is the value of y when x is 0? Well, I can look right here and I can see that it's 0. I can also look and see that it's touching the y-axis at the origin, so at the point 0, 0. So my y-intercept is at the point 0, 0. All right, I don't see a 0 necessarily in my equation. I see it up here with the original one, but I don't see a 0 over here. You could, if you wanted to, think about that as 3/4 x plus 0, and then that kind of helps me notice that, hey, that's where that 0 is going to be. So let's take a look at the next one. Go ahead and identify the slope. So again, through your table with change in y and change in x, or you're welcome to go look at your points in your graph. So I'm going to pick those 2 points. Looks like I'm going up 2 and over 1, 2, 3, 4, 5. And that is going to the left, so that's going to be a -5. So my slope is change in y over change in x. So I went up 2 and I went over, or to the left, -5. And just to clean that up, I'm going to put that negative either with the 2 or just out in front. So my slope is -2/5. Now this is pretty cool. Look, there's a -2/5 right there. It's that thing that's with the x value. It's the term that's with that x value. Let's identify where the y-intercept is at. Well, there's the y-intercept. It's touching the y-axis right there. I could also identify that from my table. What is the x value when the y value is 0? Sorry, other way around. What is the y value when the x value is 0? Well, the y value is 1. So our y-intercept is at the point 0, 1. And then notice where that's at in my equation. There's that +1. So some really cool things we kind of were able to notice with our slope-intercept form and with graphing this equation. So let's make a few notes about what we noticed. There's this really amazing, wonderful, very easy to use form called slope-intercept form. And you're going to, if you think about it, it's going to give you the slope and the y-intercept. So slope-intercept form looks like y equals mx plus b. M is our slope, so change in y over change in x, and this plus b at the end, this is going to be our y-intercept. And that's what our slope-intercept form is going to look like. Now, things to take notice of, this only works when it's in terms of y equals. So notice this is in terms of y equals right here. That's how I can quickly go through and identify the slope and the y-intercept. When we were looking at that first example, the 3x minus 4y equals 0, it doesn't look like y equals in this form. So then notice I can't make any generalizations about it. I can't find the slope and I can't find the y-intercept until I do a little bit of work to it and I get it to look like y equals 3/4 x. Then I can quickly look at it and be like, there's my slope of 3/4 because that's the term that's with my x. And then it's like a +0 on the end. So that tells me the y-intercept is going to be at 0. So let's try a whole bunch. You guys have 6 blank graphs in front of you, and let's just do it. So y equals 2x minus 3. The 2 is going to be my slope. Now, I don't love how this 2 looks. My brain really needs to see a numerator and a denominator, so that way I know what my rise and my run is going to be. So if this is just a plain old 2, you could rewrite that as 2 over 1, meaning we're going to go up 2 over 1 in the positive direction. If this is minus 3 right here, that tells me my y-intercept is going to be at the point 0, -3. So that's where I'm going to start. I always have to have a starting point, and the y-intercept is going to be that starting point. So from that point, I'm going to go up 2 over 1 in the positive direction. And I can do a whole bunch of points right here to make up my line. I can also notice go down 2 and left 1. And that's going to follow that same positive direction pattern that we're looking for. And then draw me a nice, long, pretty line with arrows on the end. All right, next up, let's try 1/3 x minus y equals 5. This one is not ready to go. It is not y equals. So we need to do a little bit of work to this to get it to look like y equals. So I'm going to go ahead and subtract 1/3 x from both sides. So this leaves me with negative y. There's still that pesky negative sign in front. And I'm going to put the negative 1/3 x in front. It would be fine if you wrote 5 minus 1/3 x. That is completely equivalent to it. But since our slope-intercept form looks like y equals mx plus b, my brain really likes to see that x term first, because then I know exactly where to go to identify my slope. Now, we're not ready yet because that says negative y equals, and I need positive y equals. So let's go ahead and divide every single term by a -1. Negative y divided by -1 is positive y. Negative 1/3 divided by -1 is positive 1/3 x. And 5 divided by -1 is -5. Now, that definitely took some work, but totally worth it, because now my slope is 1/3 and my y-intercept is at the point 0, -5. So let's get that graphed. 0, -5, up 1 over 3. Also, you could go down and left. And we get a nice pretty straight line. All right, try another one. Oh, how about y equals 5? So this is a y equals line. That's great. There is no slope. So that's almost like y equals 0x plus 5. That means that my y-intercept is at the point 0, 5. That's my y-intercept. And since there is no x term, it's a 0x. From that y-intercept of 5, I'm going to have a slope of 0. That means there's no rise. And my run, well, my run is arbitrary. I'm just not going up any, but I can go left and right because I have a 0 slope. So there's another way to think about graphing those horizontal lines. Let's look at graphing a vertical line. So x equals -4. Notice this one has no y value. And this just tells me that x equals -4. So this tells me I have actually an x-intercept at the point -4, 0. Because remember, that tells me every single x value is -4. And I don't have, I have an undefined slope here because I'm not moving left or right any. So that means I'm dividing by 0, which isn't okay. Like, we're not allowed to divide by 0. So whenever we have that x equals line, it's going to be just that vertical line through that x value. Let's take a look at x plus 2y equals -6. Again, this one is not in the form that I want it in, so we can go ahead and rewrite this as y equals. So let's take away the x from both sides. This is why those equation solving skills are so handy. So 2y equals -x plus 6. And then we're close. I don't want 2y, I want just y. So everybody is going to get divided by 2. So 2y divided by 2 is going to be just y. Now -y divided by 2, this one's a little bit tricky. I'm going to sneak in a 1 in front of that x to make it look like a -1x. Because now I can think about it like a -1 divided by 2 is a -1/2. It's -1 over 2. And then 6 divided by 2 would give me 3. Now this one is ready to get graphed. My slope is -1/2. My y-intercept is going to be at the point 0, 3. So find the y-intercept. That's always our starting point. And we're going to go up 1 over 2 in the negative direction. Or down and right. That still follows that same negative direction pattern. And then I'm going to play connect the dots. And we've got that one graphed. I believe this is my last one for our examples here. So again, 3x minus 4y equals 8. This one doesn't look great. So we're going to spend our first few moments here getting this in y equals form. So let's take away 3x from both sides. So -4y equals -3x plus 8. Remember, you can't take -3x and 8 and add those together because they are not like terms. And then I don't want -4y, I want y all by itself. So we're going to have to divide both sides by -4. That's going to leave me with y equals on the left. And -3 divided by -4 is +3/4 x. And 8 divided by -4 is going to give me a -2. So there's my slope, up 3 over 4, and my y-intercept is going to be at the point 0, negative 2. So find that on the y-axis, and then up 1, 2, 3 over 4. Or down 2, 3 and over 4. And then I'm going to play connect the dots, and there's my line. All right, for homework tonight, I have uploaded a document, and I'll title it Day 26 Slope-Intercept Form Homework Worksheet. When you print it out, it is going to be 4 pages. The last 2 pages are going to be the answer key, so that way you can just check yourself and you know right away if you have them correct or not. And then I would like you to scan them in and upload them into that D2L Dropbox. If you have any questions, please email me. Please let me know, whether it's about the lesson or just about getting it uploaded into that Dropbox. We really, really love slope-intercept form. It makes things just fantastic to graph. So good luck. There's 12 problems on the homework, and I will tell you they're beautiful. They're already in y=, form, so you guys just have to get them graphed. I would love to see all the information off to the side, like what we have here. I would love to see that you've identified the slope and the y-intercept for each of them, and then go ahead and draw your picture. All right, team. Thanks.